Hello children, in today's class we will be solving the numericals based on resolution of vector. But you might be surprised by seeing the video which is shown in the background, right? Yes. Children, can you guess the movie name? Yeah, it is one of the India's best movies, right? It is a triple R movie. So don't worry or don't get confused. We are not going to discuss about the movie here. Our interest is only on this the fight which is between the junior NTR, one of the India's best and finest actors, right, and with a tiger. So during this fight, children, if you can notice here, our junior NTR exerts force on the rope, right? Yes, but is he applying the force vertically or horizontal? No, neither horizontally nor vertically. He is applying the force with a certain angle, right? So whatever that force which is applied by our junior NTR can be resolved into two components. So the horizontal component is cos theta, children. The vertical component will be sin theta. So this is actually today's a very important point to solve all the numericals. Okay, now by using this concept, like a horizontal component is a cos theta, vertical component is a sin theta. Today we are going to solve all the numericals. So let us say thanks to our junior NTR and let us start today's concept and numericals. Now let us see here, children. So in these two diagrams, vector A is making angle theta. How this vector can be resolved? Children, this is a point what actually we are going to use in today's entire discussion. Children, here as vector A is making angle theta with the x-axis, so its horizontal component is going to be A cos theta and its vertical component is going to be AY is equal to A sin theta. Clear? But here what is the horizontal component? You can't say it is a cos theta. That's what. So this is a very, very important part. You have to see that resultant vector is making angle with whether it is x-axis or y-axis. So the axis with which it is making an angle, that is going to be the what? Horizontal component here, A cos theta, and this is going to be A sin theta. Is it clear, children? Fine. Children, if you need a in detail discussion about this resolution vector, link is given in the description. Just kindly go through those videos. So that what will happen, you will get a good command. Okay, fine. Now just copy this. We will start the numericals based on resolution of vectors. F is equal to how much? Children, first let us see the numerical 1. Children, as per the numerical, it is given that a force of 15 Newton is acting on a body such a way that it is making 60 degrees angle with a horizontal. Now they are asking us to resolve horizontal component and vertical component. Means in that they are asking us to find the horizontal component of the force, vertical component of the force. Okay, fine. So as we know that here is, let us resolve into two axes. Let us say the x-axis and here is a y-axis. Children, it's not x and y also, two rectangular components. Now we know that the angle, see the resultant vector making an angle theta with this horizontal axis. So the x component is going to be f cos theta. Now obviously the other component is going to be fy is equal to f sin theta. Now you substitute here fx is equal to f, in the place of f just you can substitute 15. Now it is cos 60 degrees here. So this is 15 into, children, cos 60 is how much? 1 by 2. So this is 7.5 Newton. Children, this is the horizontal component of the force of 15 Newton which is acting on the body with a 60 degrees angle. Now vertical component is, come on, similar way, fy is equal to, in the place of f substitute 15 and now it is sin 60. So this is 15 into sin 60 is how much? It is the root 3 by 2. So this is 7.5 root 3 Newton. If you want, you also can simplify more by substituting 1.7 in the place of root 3. Simple ones, rectangular components. Now second one, children. So here it is said that here a body of mass 2 kg is lying on an inclined plane such a way that there will be an angle 30 degrees with the horizontal line. Now they are asking us to resolve the weight of the body into two components. One should be parallel to the plane, another should be perpendicular to the plane. Children, these are very important and most of the students get confused here only. Let us see here. Okay, first let us take a general one. Okay, this is inclination. Okay, here is a body whose weight is, okay, W, that is mg. Let us say that it's a mg. Let us say here is a theta, children. Okay, na? So let us apply the rectangular component. What we can say is a concept. So one should be there asking, okay, parallel. That's fine. Let us say this. Okay, let me draw. Let us say here is a body and here is a, okay, let us say this is parallel to the what inclination and next one is perpendicular. So perpendicular to the inclination is going to be this. So this two they are asking us to calculate first. Okay, now if its mass is m means weight is going to be mg, no doubt about it, and weight of any object acts vertically downwards. So here is, this is W is equal to mg. Actually the weight of the body always will act vertically downwards. Now look at here, children. Here is a theta. This is 90 degrees. Yes, 90 degrees. It is a 90 is a theta and this is going to be 90 minus theta. Am I right, children? Yes, obviously, because inside, you know, the total angles should be 180. So 90 minus theta. But don't you think that, children, this is 90 degrees? Yes, because vertical component to the plane. So as this total is 90, 90 minus theta is left. Obviously, this is going to be theta. Children, understanding this angle is a very important. You see theta. So which means what here? Here is a theta, here also theta. Now just apply this concept. So if the resultant vector is make an angle theta with some axis, so along with that we will get a cos theta component. So now here we are going to get a mg cos theta. Obviously this is going to be a mg sin theta. mg sin theta. Children, it's very important. So here vertical component to this, children, try to understand, don't get confused. For this inclination, vertical component is going to be mg cos theta and parallel component is going to be mg sin theta. Now what they are asking? They are asking us to calculate the parallel component and the vertical component to that inclination, right? So now here parallel component formula, let us use mg sin theta. So m value is 2. Okay, g let 10 meter per second square. So that is into 10. Sin 30. Sin 30 is how much, children? 1 by 2. So this is 10 Newton. So 10 Newton is a parallel component of the weight along the inclination, children. For inclination it is a parallel. Don't get confused. Okay, fine. Now vertical component they are asking. So that is mg. M is 2. G is 10, but now it is a cos 30. Cos 30 is root 3 by 2. So this is 10 root 3 Newton. Here is a vertical component of the weight to the inclination. Clear? Fine. Now with this concept, third numerical is going to be very easy. So as per the numerical, children, it is given that a body of mass 10 kg is placed in inclination such that the angle making the horizontal is 60 degrees. Now obviously as the body is, you know, placed in inclination, it might be a frictionless surface, then obviously the body will be sliding down. But they are asking what should be the force applied so that the body won't slide at all. Won't slide at all. So here logic we need to apply. Logic we need to apply. Let it is sliding with a certain force, right? Some force is pulling it. Okay. Now if it is x amount of force is pulling downwards, then if you apply x force exactly upwards along the inclination, then body will be stopped. Equal and opposite, right? Downwards 10 Newton, upward 10 Newton. Downwards 100 Newton is acting. You apply 100 Newtons upwards along the inclination, then the body will be stopped. So now what we have to calculate? Indirectly, we will calculate with what force the body is sliding downwards. So we calculate that. So then obviously what will happen? If same amount of force applied, then the body will be stopped. So indirectly we have to calculate the what we have to calculate, children? Look at here. So here we need to as per this, we need to calculate the parallel component of the weight we need to calculate. So that is going to be F parallel is equal to mg sin theta. So m is 10, g let take 10, sin theta, sin 60 is root 3 by 2. 2 ones are 2 5s are. This is 50 root 3 Newton. Children, if you want, again I am telling you, in the place of root 3 you can substitute 1.737 value and you also can do it more. Clear? So this is how. See, you should be very careful with what axis the angle is, the resultant vector is making an angle. So along with that axis, you have to take the cos theta component here also. So this is what actually here is. So W is here is the resultant one. With this only, this component of the weight is making angle theta. That's what. Along with this axis, we have taken cos theta component. Is it clear? Just copy it. V square. Fine, children. Now let us see the fourth numerical. As per the fourth numerical, children, it is given. Children, this question, we need to think logically actually. It's not a directly it is given. So here a particle or some bird or object is moving with a velocity of 100 meter per second. So that is the velocity is given, resultant velocity. And it is also given that one of the rectangular components is 50 meter per second. One of the rectangular components. So there are two rectangular components, horizontal component and a vertical component. Here you may get one doubt. So then which one we should consider? It's up to you actually. You can take it as a horizontal component. You can take it as even vertical component also. For sake of my convenience, let us say our convenience, I have considered that one of the rectangular components of this velocity is 50 meter per second. Now they are asking us to calculate the magnitude of the other component and the angle with which it is made with the resultant vector. So if you can take it as a Vx, you need to calculate Vy, or if you can take it as a Vy, you need to take it as a Vx. That's it. Okay. Now children, we know that here. So here is, let us say it's a velocity vector and it is making an angle theta with the horizontal and let us say vertical. So here this is going to be a horizontal component, this is going to be a vertical component. So resultant vector can be written like this, right? V square is equal to Vx square plus Vy square. Now we need to calculate Vy actually. We need to calculate Vy. So make it as a Vy square is equal to V square minus Vx square. So from this, children, I can write like this. Vy is equal to square root of V square is how much? It is 100 square minus Vx is how much? It is the 50 square. Now this is going to be a 10000 minus 2500. So this is going to be a 7500, and if you can simplify this, you will get it as a 50 root 3 meter per second. So this is a 50 meter per second is given one of the rectangular components, and we calculated the another rectangular component as 50 root 3. Now they are asking us to find the angle. Yes, let us take either a horizontal component or vertical component. Children, let us take Vx is equal to, we know that is a V cos theta. So now can I write like this? Cos theta is equal to Vx by V. Yes, Vx is how much? 50. Okay, 50, and V is how much? This is V, children, resultant one. So it is a 100. So this is going to be a 1 by 2. So here cos theta is equal to, for what angle of cos, children? The value will be 1 by 2, that is cos 60. Cos 60 degrees. As cos theta is equal to cos 60, theta is equal to 60 degrees. Very simple. Don't get confused at all. Okay, fine. Come to the fifth numerical, children. It is given that a particle is moving with a 60 meter per second towards east, and all of a sudden it takes turn towards north with a 8 meter per second velocity. So means here we have a velocity along the east, we have velocity along the north. Means we actually don't have the what is a reserve velocity, magnitude of the velocity of the particle actually. So now they are asking us to calculate the velocity, and there will be a change in the direction of the velocity, there will be some acceleration. So they are asking us to even calculate the acceleration of that particle also. So now So how to calculate? Come on, it is the east and north. Acha. As per the children concept of a parallel shifting of vectors. Yes, any vector can be shifted parallel to itself because there won't be any change in direction, there won't be any change in magnitude. Now this vector of velocity I am going to make here. Can I? Yes, even if not, you can take this velocity here also, no problem. Okay, for sake of our comfort. Okay, so let us shift the vector which is going towards the north with what velocity? 8 meter per second. 8 meter per second. Now resultant vector is this only, na? Yes. So now they are asking us to calculate this. This is how much? This is nothing but horizontal component, children. Here is what actually vertical component is given. Come on. So we know that V is equal to, yes, apply this formula. V is equal to square root of Vx square 6 square plus Vy square 8 square. Let us simplify this. This is going to be a 36 plus 64 and this is going to be a 100, right? So this is a 10 meter per second. So this is the magnitude of the velocity they asked. Now even as there is a change in the direction of the velocity, definitely it has some acceleration. So how to calculate the acceleration, children? Yes, acceleration is equal to velocity by time. So velocity is given 10, time is 10 seconds. So here is a 1 meter per second square. It is a simple concept of kinematics it is. Here you don't need a vector knowledge. It is a simple concept of kinematics. Okay, done. Now come to sixth numerical. Children, here as shown in the figure, let us say here one particle. 3 forces are acting, 10 Newton, 20 Newton, 30 Newton as shown in a figure. Now they are asking us to calculate the resultant force acting on that. So if you want to calculate the resultant force, first we must resolve all forces acting on the particle into horizontal components into vertical components, that is along x-axis, along y-axis. Then only we can calculate first resultant of the forces along the vertical component as well as along the horizontal component. Then we can calculate the resultant. First let us try to resolve the forces which are acting on the particle. Children, let us say this is F1, don't get confused. It is F2, it is F3. You can take it as a F1, it as F2, it is F1. It's up to you. It's not a big task here. Okay. Now children, so here this F1 force is making an angle 30 degrees with this horizontal line, right? So this is going to be what, children? Come on, along the horizontal component, cos theta. So this is going to be a, so let us say F1. F1, this is, okay, this component is going to be 10 cos 30 and vertical component is going to be like this. So here is 10 sin 30. So this force we resolved into two rectangular components along horizontal, along a vertical. It's over now. This is over. You forget about this force now. Forget about that. Now come to this force, children. This force here. And here one more thing is there, children. Here whenever you are resolving a component, here 3 are there. Forget that 3 are acting. Think that only 1 is acting. Resolve that. Resolve that so that it will be very, very easy. Now I want to resolve this 20 Newton, right? Now I should forget about these two forces and everything I should forget because there will be confusion again. Okay, fine. Now children, it's a 20 Newton, okay, along the horizontal component because it is making an angle, right? So this is going to be a 20 cos 60 and along vertical component 20 sin 60. So second force also we resolved. What about third one? Third one is not at all making an angle. It is already along the y-axis. No need to resolve. Now let us see vertical components, horizontal components, children. Now first horizontal components, let us see. Horizontal components. So this is a summation of horizontal components. So this is 20 cos 60 minus 10 cos 30, sorry, 10 cos 30. So this will be 20 cos 60 is how much, children? 1 by 2 minus 10 cos 30 is how much? Root 3 by 2. 2 ones are 2 tens are. So this is 10 minus 5 into root 3 is how much? Approximately let us take 1.7. Approximately we are taking. So this is going to be a 10 minus, this will be how much? 8.5. So this is going to be a 1.5 Newton. Here you might have got one doubt. Sir, why are you doing 20 cos 60 minus 10 cos 30? Why not 10 cos 30 minus 20 cos 60? Children, whenever two forces are acting on a body, if you want to calculate the resultant one, so always you know how we should do. The force with a smaller magnitude must be subtracted from the force with a higher magnitude. It is our common sense that yes, 20 cos 60 value is more than this. For suppose if this value is more than this, then this minus this you should do. Then itself you have to take a decision. Clear? Fine. Now children, vertical components. Now let us take a here along the vertical. So that is summation of V is equal to, yeah. Now if you can see, obviously 30 is more than that of this. Again, don't get confused. So here I can do 30 minus 10 sine 30 minus 20 sine 60. Are you able to see this? Let me check. Okay, little bit. Yes, fine. I think we need a space. Can I erase this? Hope you might have copied this. Yes. Now look at here. Oh, why it is not erased properly? Yeah, board has to be cleaned properly. Yeah, fine children. So now, so vertical component is going to be, okay, this is 30 minus, so 10 sine 30 children. 10 sine 30 is 1 by 2 minus 20 sine 60 is root 3 by 2. Let us simplify this. 30 minus 5 minus, this is 10 into 1.7, this is going to be a 17. So 30 minus 22 is going to be a 8 meter per second. This is also meter per, sorry, it's not a Newton, sorry, it's a Newton, then it is going to be a Newton, sorry. Fine. Now resultant vector they are asking. Here we got a horizontal and resultant of horizontal components, resultant of vertical components. Now this is what actually we have to use the formula. So now resultant is equal to square root of, so square of the horizontal components, how much is that? 1.5 whole square plus 8 whole square. So this is going to be a 2.25 plus 64. So this is going to be 66.25 Newton. So this is how we can calculate the resultant of the forces which are acting. Children, let more than 3 forces act, no problem. But as I told you that when you are resolving about a one force, you feel as if only one force is acting, other forces are not acting. Then there won't be any confusion at all. After that, just see along the horizontal axis and along the vertical axis. With that, what will happen? Numerical will become very simple. Okay. Three meters. Fine children. And here 7th numerical is very interesting. So you might be knowing about the billiard game, right? It's now our interest is not to talk about the game and everything. So when in that board, you know, that ball will be moving. It's like how a carom board cards will be moving, which means what? It is a most of the particle in a plane actually. So individual children, one, let us say it's the first billiard ball, individual we are thinking first. So first billiard ball is moving in that plane such that it has a horizontal component as a 1 meter per second, vertical component as a root 3 meter per second. Okay. And another ball is also moving in the plane such that its horizontal component is a 2 meter per second and a vertical component also 2 meter per second. Oh, is it the same? Let me check. 2 meter per second, 2 meter per second. Is it given both same? Let me just, I got doubt. 2 meter per second, 2 meter per second. Yes, it's true. Fine children. Now, if the two balls, see obviously individually if they are moving, definitely they will make some angle with the horizontal line. Now, if the two balls will start from the same origin, then what is the angle between the two balls, children? Angle between the two balls. It is not a direct numerical, it's an indirect numerical. So first, because you know we don't know with what angle they are moving with the horizontal one. So first let us calculate this theta 1, theta 2. Once you can calculate theta 1, theta 2, that difference is going to be the angle between the two billiard balls. So here, right on. First let us calculate this, children. So we know that, see, and here is let us say y component and here is a x component and here is the resultant vector. If it is a theta, then we know that it is a tan theta is equal to, sorry, this is y, right? Extremely sorry. It is a x. Then it is a y by x. So same formula which we are going to apply. First for this, let us apply, children. So for this, tan theta 1 is equal to, so y component is root 3 by x component is 1. So tan theta 1 is equal to root 3. Achha, for what angle tan takes root 3, children? So this should be root 3 by 2 by, so it's a 60 degrees. So this is a tan 60. So here we got theta 1 is equal to 60 degrees. That is fine. Similarly, let us calculate for this also here. Okay. So here tan theta 2 is equal to, y component is 2, x component is 2 only. Both will get cancelled. So tan theta 2 is equal to 1. For what angle of tan it takes 1, children? It is a 45 degrees. Tan 45. So theta is equal to 45 degrees. Now these both actual what they are asking, let us have the feel, children. So here is, let us say it is a billiard, that board, let us say that it is a x and here is a y, and it is a first ball, children. This is, let us say, first ball is make an angle theta 1. Okay, it's very clear. And the next one, this is second ball, it is make an angle theta 2. This we calculated, but they are asking us to calculate the angle between the two billiard balls. So this one has to be calculated. This is what actually resultant angle. So resultant angle theta 1 minus theta 2, that's it. So theta r is equal to 60 minus 45. It is going to be a 15 degrees. So don't get confused. It's very simple. Okay, fine. And come to the next numerical. Children, I need a space here. Can I erase this part at least with your permission? Yes, okay, yes, fine. Now, a particle is moving with some velocity. After time t, children, its a x component is ct square, y component is bt square. Now, they are asking us to calculate the magnitude of the velocity. So first let us calculate the horizontal component of the velocity, vertical component of the velocity. So here x and y are nothing but what's displacement. But how can we get the velocity, children? Yes, it is a concept of kinematics. The rate of change of velocity gives you what? Velocity. Sorry, the rate of change of displacement gives you the velocity. Okay, first now I want to calculate the horizontal component. For this, let us dx by dt. So this, sorry, dt in terms of t, right? So d by dt of c t square. So anyhow here c is a constant c, and here dt square by dt, we are using the formula d by dx of x power n is equal to n into x power n minus 1. Here we are not going to discuss the differentiation concept, but still this formula, just I want to, it's my responsibility to tell that which formula we are using to make it. So this is a formula. So as per that, children, so this is going to be c into 2 into t power 2 minus 1. So this is 2ct. This is a horizontal component of the velocity. Similarly, vertical component is going to be dy by dt. So this is d by dt. So y is given bt square. So this is also going to be directly what, children? 2bt meter per second. Yes, here also let us write meter per second because it's a velocity. Now resultant one, children, yes, v is equal to square root of, it is vx square plus vy square. So this is going to be 4c square t square plus 4b square t square. So 4t square you can take as a common, so that it will become 2t and a square root of c square plus b square meter per second. Is it correct? Let me check with the answer so that we'll come to know that whether the given question is right or wrong. 2t c square plus b square. Yes, it is the right answer. Okay, sometimes students will get a confused or tensed when variables are given. In fact, children, when variables are given only, it's very easy actually. Okay, now fine. Now come to the ninth numerical. It is given that p is a vector and it is given that its horizontal component is 4 root 3, vertical component is minus 4 meters, it is given. First make a rough diagram. You make it a one down. Sir, why are you taking what py is downwards, children? Yes. Think logical. It is given minus. So along minus y axis only we should take. Okay na? If you would have given like minus 4 root 3, if then we would take in this direction. Okay na? That is the logic. So now yes, resultant vector is going to be p is equal to square root of px square plus py square. So this is going to be, this is square means how much, children? 4 4 is 16 into 3, 48 plus 16. So this is how much, children? It is 58, 64. So this is going to be a 8 meters. This we got fine. But now they are asking us to calculate the, okay, this we got 8 meters, no problem. They are asking us to calculate this angle, right? This angle they are asking us to calculate. Okay, how to calculate? How to calculate? Same concept. Tan theta is equal to y component by x component. Yes, let us make it. Tan theta is equal to y component is minus 4, x component is 4 root 3, 4 4 cancel. This is going to be minus 1 by root 3. Okay, so tan theta is equal to minus 1 by root 3. Angle is how much? Children, actually we know that 1 by root 3 is what for a tan 30. So it is a minus tan 30, right? Okay, minus tan 30. So minus for tan means it will be in a fourth quadrant. So this can be written as tan 360 minus 30. Children, tan 360 minus 30 is nothing but minus tan 30 only. Okay, fine. Now this is going to be a tan theta is equal to tan 330. So theta is going to be 330. That's it. This is how we can calculate the angle of the resultant vector. Clear? Copy it. We'll move further. It's equal to how much? Children, this 10th and 11th numericals are very important, very interesting also. Here some imagination is needed for us. Okay, fine. So as per the question, children, a bird is flying. So here is a bird. Okay, please excuse me. So bad diagram. Okay, let us, here is a bird. It is flying with a 20 meter per second. Such a way that, children, so bird is flying in a space. This concept is not related to the plane. It is a space actually. So let us say that here is what we can say, this is eastern line along the x-axis. Okay, eastern line. Okay, then this is going to be a northern line, and this is a vertical line to these two. Okay, so bird is flying like this. In a plane it is flying such a way that it makes an angle 60 degrees with the eastern line and 60 degrees with the vertically upwards, that is along the z-axis. Now they are asking us to calculate the resultant velocity of the what we can say that bird. So indirectly we need to write the velocity in terms of vector component, that too in a space, children. So if it is in a plane means v is equal to vxi plus vyj, but in a space means yes, vector v can be written as here vx I cap plus vy j cap plus vz k cap. But here the question is that what is the vx, what is the vy, what is the vz? Yes, this can be written here, children. So v cos theta I cap, or let us say it's alpha with x-axis alpha, plus v cos beta j cap plus cos gamma k cap. It's fine only. But the problem is that here we know alpha value, okay, we know gamma value, beta value is not known. That has to be calculated. Okay, now. So here only we have to use the concept of direction cosines. So we know that, children, here cos square alpha plus cos square beta plus cos square gamma is equal to 1. Use the relation. So cos square alpha is how much? Cos 60 is 1 by 2. So 1 by 2 square. Okay. So cos square beta is not known. And here also cos square gamma is a 60. Cos 60 is a 1 by 2. So 1 by 2 whole square is equal to 1. So it is children, it is a cos square beta is equal to 1 minus, so this 1 by 4 plus 1 by 4 is a half, 1/4 plus 1/4 half. So this is going to be a 1 by 2 only. As so cos square beta is given how much, it is a 1 by 2. Then cos beta is equal to how much? 1 by root 2. For what value of cos beta it takes 1 by 2 children? Yes, beta should be a 45 degrees. That's it. Now substitute the values in this. Substitute the values in this equation. So here V is equal to vector form. So magnitude, that is a 20 cos 60 I cap plus 20 cos 45 j cap plus 20 cos 60 k cap. So this is going to be a, so children, cos 60 is how much? 1 by 2. So that is 2 will get cancelled. So let us write 1 by 2 I cap plus 20, it is 1 by root 2 j cap plus 2 into 1 by 2 k cap. You can simplify more. Sorry, here is a vector in a space. So this is I cap plus, so children, this can be written as 20 can be written as 2 into 10. Again the 2 can be written as root 2 into root 2. So root 2 will get cancelled. Here it is a root 2 10 j cap plus k cap meter per second. So let us cross check with the answer. Yes, 10 I cap plus something is wrong. Hey, this is 20. I'm very sorry. This is 20. So obviously this is 20, right? So this is 10 I cap. So this is also 20. Sorry, this is 20. So then this is going to be a 10 k cap. That's it. So the answer is, so 10 I cap plus root 2 10 j cap plus 10 k cap meter per second. That's it. Is it clear? Are you able to see? Yes, you are able to see that. Fine. Have you copied this? Okay. Now come to the next numerical. It's one more wonderful numerical. Wonderful. Yes. So recently I got a message in a comment by saying that, sir, everything you'll say it's very important, most important, wonderful numerical. Yes, children. So you should be very positive towards the numericals, right? So we should not think that it's a very tough numerical, not important numerical. Then our brain won't respond properly. The moment when you think that it's a very important numerical, it's a very easy numerical, then what will happen? Your brain will, respond properly, and you will get a kind of motivation to solve the numericals. Okay, fine. Chalo. So as per the numerical, children, it is given that here one boat is moving with 18 km per hour along the northwest, children. Northwest. Yes. So first you make a east, west to north, south. So northwest means this only. Undoubtedly it is a northwest only. It makes 45 degrees with west, 45 degrees with the north. But you should get one doubt, sir, why you have taken 45 degrees here? Why not here? They mentioned a northwest. North means north of west, towards north from west. If it was west north means we would have taken like this. Children, don't get confused here. It is a northwest, so that we have taken an angle with the west. If it was a west north means we should take 45 degrees with the north. Is it clear? Fine. And also it is given that that boat is moving such a way that the shoreline is making an angle 15 degrees with the southwest. Here, so it is making, try to understand, the shoreline is making an angle 15 degrees with the southwest, children. Southwest means what here? West, see, towards south of west. Southwest means what, children? Again I repeat once. Towards south from west 15 degrees. Now they are asking us to find the vertical component and parallel component to the shoreline. They are asking to the shoreline. So first, if you want to know that, first you should know what is the angle made by the boat with the shoreline. First we should know that. So here it is 45 plus 15. Yes, this is a total angle made. Children, don't get confused. Let me highlight this. Okay, yeah, this is, so this is the angle made by the boat with the shoreline. They are asking to calculate the velocity of the boat perpendicular to the shoreline, parallel to the shoreline. Then we must know the angle made by the boat with the shoreline. That is first step, children. So 45 plus 15, yes, 60 degrees. Okay. Now we have to calculate the, yes, horizontal component. Let us say it's a V1. Okay. And the vertical component to what, children? Shoreline. Try to understand. Let us say it's a V2. So V1 is nothing but VB cos theta. V2 is VB sin theta over, are you able to see? Let me check. Yes, you are able to see. So now it is V1 is equal to VB is how much, children? 18 cos 60. Cos 60. This is 18 into, it is a 1 by 2. So this is, children, V1 is nothing but what, children? It's a parallel to the shoreline is 9 kilometer per hour actually. Sorry, it is a per hour. Per hour. Okay, fine. Now V2 is what? Perpendicular component of the velocity of the boat to the shoreline. Perpendicular. It is what actually? VB 18. This is sin 60. So this is 18 into, it is a root 3 by 2. This is 9 root 3 kilometer per hour. Just copy it. Done? Yes. Come to the 12th question. It is based on the equilibrium, children. So the forces are acting as shown in the figure. Now they are asking us to calculate. See, whenever, children, so whenever a string is stretched, definitely a kind of force will come into play, is called as a tension. Now here tension T1, here tension T2. Now they are asking us to calculate the ratio of the T1, T2. First, if you want to calculate the ratio of the T1, T2, first we must know T1 value, T2 value. For that, yes, these tension so-called forces to be resolved into horizontal and vertical components. Let us do it. Come on. So actually, just please excuse me. This has to be exactly perpendicular like this. Let us say yes, force F is acting like this. Okay, fine, children. First to T2. Yes, this is going to be a T2 cos 30 horizontal component, and here is T2 sin 30. That's it. So in equilibrium, children, in equilibrium, yes, definitely T2 sin 30 must be equal to F. So this is T2 sin 30 is 1 by 2. This is F. So T2 is equal to 2F. So we got here T2 value in terms of force we got. Don't get confused. Don't get confused. Later. So now it's see, and it's also, you know, we may guess that yes, T1 also we are going to get in terms of F only, definitely. So here T1 is equal to T2 cos 30. Children, why are we equating? Because it is given that equilibrium. In equilibrium, this horizontal component must be equal and opposite, and these two also must be equal and opposite. Okay, we are taking magnitudes. So here T1 is equal to, so T2 is what, children? Yes, 2F. Okay, cos 30 root 3 by 2. 2 cancel. So T1 is equal to root 3F. Now what they are asking? They are asking us to calculate the ratio, right? Yes, T1 by T2 is equal to root 3F by 2F. F cancel. This is going to be a root 3 by 2. So T1 is to T2 is equal to, this is going to be root 3 is to root 3 is to 2. That's it. Children, don't get confused. See why we are equating? Because it is given that this particular point, so-called particle or object, it is in equilibrium. That you should not forget. Okay, just copy it, and we do one thing. Like this numerical, we'll try to solve 2 more or 3 more so that you get a good command. Okay, copy it. So here is T1 and T2. We need to calculate the either ratio or T1, T2 individually. It's not a problem. Yeah, children. See, simply, children, it's a resolution of the vector component only. All numericals, different numerical we are solving, but the same concept. Fine, children. Here it is given that initially the simple pendulum is like a suspended like this. It is pulled aside with a certain force like this, such that now it is making an angle 30 degrees. That is what actually you have to imagine. Okay. Now they are asking with what horizontal force it has to be pulled, and what is the tension, and if possible calculate the ratio of these two also. Okay, fine. So for children, this has to be resolved. See, we know that its weight will be acting downward direction mg. Okay, no doubt about it. Now this is, children, can I resolve into tension to two components? So this is going to be try to understand how much weight is. Okay, and vertical component, look at here. Okay, now the surprising thing is that opposite angles are equal, right? So this is going to be 30. This is going to be 30. Then obviously this will be t cos 30, and this is going to be a t sin 30. Okay, fine. So here you can even resolve mg also. It's not a problem, children. Now if you can see in this case actually, okay, so f is equal to t sin 30, and we also know that here mg is equal to t cos 30. Okay, these two equations, let us divide these two equations. Then f by mg is equal to tt will get cancelled, sin 30 by cos 30 will be tan 30. So from this f is equal to mg tan 30. So is mass given? I didn't mention on the board. Is mass given? Of course, I think 0.05 is given. Sorry. So your mass is given, children, it's a 0.05, and g you can take as a 10. So this will be 0.05 into 10. So tan 30 is how much, children? So tan 30 sin 30 1 by 2 by root 3 by 2. So it is a 1 by root 3. So this is going to be 0.5 by root 3. So if you can simplify this, how much you should get? You should get it as 0.5 means, yes, so it should be 0.58 newtons. Okay, fine. Now children, so in equilibrium t cos 30 must be equal to mg, right? Yes, let us use that only. T cos 30 is equal to mg. So t is equal to m is 0.05, g is 10 by cos 30. Cos 30 is how much? Root 3 by 2. So this is going to be a 0.5 into 2 by root 3. Okay, so if you can simplify this, how much you will get? I think, children, so this is 0.28 if I am not wrong. Kindly check now, once you check 0.28. So this is going to be a 0.56 Newton. 0.56 Newton. So this is how force, this is how tension. In exam, if they'll ask you to find the ratio, either F by T. So F by T means 1 by 2 you will get. T by F means 2 you will get. That's it. Okay. So what is the ratio? 1:2 you will get. So let us try this, right? Okay. So if you want like a F by T ratio. So this is 0.28 by 0.56. So it is a 1 by 2. So simply say F is to T is equal to 1:2. That's it. Okay, as simple as that. Yes, come to the 14th numerical. Children, by seeing the diagram, don't get confused, don't get tense. It's simple. Just we are going to resolve the vectors. That's it. Okay. So here is given 60. Okay, no other angles are given. Okay, this is 90. Okay, fine. Now children, so this let us resolve T1. So this will be, let us say it's a T1. Okay, na? And this is going to be it's a vertical component. Let me make properly. Wait. Yeah. So this is here is 60 means, yes, this should be 60. This is T1 cos 60. This is T1 sin 60. Okay. Then what about this angle? Yes, let us see. Wait. Don't. Yeah, here something we forgot more. Here force of 20 Newton is acting, and here also making a 60 degrees. Okay, children, here is 90, 60. So obviously this is going to be a 30. So then this T2 can be resolved. Yes, this is T2 cos 60, and here T2 sin 60. That's it. Children, here we need a space, and I will take a bit space here. Hope you have copied this. Okay, so wait, so now look at here. So that's it in equilibrium, children. Yes, T1 sine 60 is equal to T2 sine 60 plus 20 Newton. So let us try to find this. So T1 sine 60 is root 3 by 2, right? So it is a root 3 T1 by 2 is equal to, here also same thing, root 3 T2 by 2 plus 20. So here if you can take this 2, this side you can take. So it is a root 3 T1 is equal to root 3 T2 plus 40. Okay, make a equation 1. This is what we have solved along the vertical component. Now let us see the horizontal components. So this is T1 cos 60. Yeah, here we made a mistake. This is 30, right, children? Okay, sorry. This is 30. It is 30. That's what I'm thinking. Why both are getting same? This is 30. So this is just T by 2. This is just T2 only. Okay, now fine. Now it is T1 sine 60. T1 sine vertical component, right? T1 sine 60 is equal to T2 sine 30. Wait, why are you getting confused? Come on. So vertical over, right? Now we need to do the horizontal. So T1 cos 60 is equal to T2 cos 30. So this is cos 60 is 1 by 2. So it's a T1 by 2. This is T2 cos 30 is root 3 by 2. 2 cancel. So T1 is equal to T2 root 3. So make it as a 2. I think you can substitute this in equation 1. So root 3 into T2 root 3. So 3 T2 is equal to T2 plus 40. If you bring this side, 3 T2 minus T2 will be 2 T2 is equal to 40. So from this, T2 is equal to 20 Newton. T2 is equal to 20 Newton. Now this T2 value, substitute here 20 root 3. That's it. So T1 is going to be 20 root 3 Newton. So this is how we can solve, children. Okay, na? Think you are able to see this. Let me adjust this height little bit. Yes, now you are able to see this. Clear? Fine, children. Now when compared with this, very simple it is. Okay, na? So here, hey, angles we have not taken. What are the angles? I think it is 30, 60 here. Oh, what are those angles? Without angles, how, man? So yeah, it's a 60, 30. This is given 60. It is given 30. Okay. Fine, children. Now here, look at here. Let us make one horizontal line. Yes. And is a vertical line. Because we need to resolve into rectangular component. So here is 30 means here is 30. So obviously this is going to be a T1 cos 30. And along this T1 sine 30. Okay. Now this is going to be this is 60, right? Okay. 60 means it is 60. T2 cos 60 and here vertically T2 sine 60. T2 sine 60. Now in equilibrium, children, yes. In the equilibrium, hope you have copied this. Yes. Okay. In the equilibrium, along the vertical axis, T1 sine 30 plus T2 sine 60 is equal to 200 Newton. Okay. So sine 30 is a 1 by 2, T1 by 2 plus 60 is root 3 by 2, root 3 T2 by 2 is equal to 200. This can be T1 plus root 3 T2 is equal to 400. Equation 1. LCM you can take right side, it will be, it multiplies. Now horizontal component it is, so it is a T2 cos 60 is equal to T1 cos 30. So cos 60 is 1 by 2, T2 by 2, this will be cos 30 is root 3 by 2, root 3 T1 by 2, T2 cancel. So T2 is equal to root 3 1, T2 is equal to, so this here what we got, T2 is equal to root 3 T1. This value you can substitute here. Then you will get T1 plus root 3 into root 3. 3t1 is equal to 400. This is 4t1 is equal to 400. So t1 is equal to 100 Newton. Now this t1 value, children, so where you will substitute, where yes, you can substitute here. Then you will get t2 is equal to root 100 root 3. So you can write as a 100 root 3 Newton. Okay, children, so these are the 15 numericals related to the resolution of vector, children. Resolution of vector. Okay, na? So again I repeat, children, here, yes, before going to watch this video, solve this numericals, once watch how actually vectors can be resolved into two dimension in a plane, not in a space. So already we had discussed long back. The link will be given. Even the videos related to the vectors also, all links will be provided in the description. So go through those videos so that you get a command. And one more, my advice is that whenever we are starting our numerical here, children, once I show the numerical, just pause the video, just try to solve the numerical, right? Whether you get right answer, wrong answer, second thing. But the thing is that just try your level best. If not, what happens? Yes, if not, again you can continue the video to watch so that you will get the solution at the end. But you have to try, because you are the one going to write the exam. It's not your teachers. Try to understand. And again I'm telling you, don't get tense, don't feel bored. You have to motivate yourself, children, because it is your career, it is your life. You are the one going to have the great career in future. So do little bit work, right? Little bit. It's my a request. Okay, it's my request. Do a little bit work, children, so that what will happen, your future will be very good. So next we'll meet one more video with I think a resolution of vector in a 3D, and next we'll be continuing the addition and the subtraction, all those things also. Okay, children, thank you so much. All the very best.